And around that time, because of course I was thinking about other things, I got very interested in, I found myself coming back and forwards to this area in which Garry Kasparov had been playing chess computers that IBM, the American manufacturers, had been designing. He'd played a couple of, like one very small, simple one, probably in about 91, 92 maybe. Then they designed a more powerful computer. There was one called Little Blue, I think. And of course, all the time, IBM are thinking, hey, if we can design a chess computer that actually beats Kasparov, the world's grandmaster, then our share price is really going to go up. So finally, they designed Deep Blue. And all along, I'd also been thinking, they spoke about recognizing the first signs of consciousness in this computer. It was so powerful. It was so enormous. And of course, it beat Garry Kasparov, finally. And there was an amazing photograph of Kasparov's face at the moment when he realized that he'd been beaten by a computer that was flashed all around the world. I'll never forget that face, which seemed to me to be a really remarkable moment. And simultaneously during this time, I'd seen 2001 some years earlier, Stanley Kubrick's film. Who has seen 2001? Okay, quite a few people. Well, you may remember there's that HAL, is the mainframe computer, of course, and HAL, who's programmed for the mission to take a particular shape, lip reads some of the astronauts plotting against the mission, and bumps some of the astronauts off, which goes against the first law of robotics, which is that a machine shall not harm a human being. But at that moment in the film, I didn't find myself at all confused about whether or not this was a potentially likely scenario in the future. In other words, having sentient machines. So I began to think about making a series of portraits of machines rather than just photographs. And I traveled right around the world to something like 60 scientific sites, NASA at Houston, CERN at Geneva. In fact, they were just beginning to make some of the very, very early stages and components of the Large Hadron Collider, which we've all heard so much about recently, because that's taken something like 14 years to get going. And these are some of the pictures. There are 11 photographs in this series from all those 60 scientific sites. 2 of them have a very different function. 9 of these images are of, at the time, in the mid-90s, some of the most sophisticated pieces of equipment in the world. But 2 of the pictures, which they'll kind of be obvious, but I'll point them out too, I see much more as sort of conceptual coordinates, like, or axes, like a vertical and horizontal axis. This was a communication satellite, so when you make a mobile phone call, this goes round the Earth at about something like 60 kilometers up. Incredibly, I had taken the perspex off the front face, so you could see in the print. These are all about 53 inches wide by 65 inches high. And in the print that size, you can see every single filament in those electricity generating cells. But actually, in space, when that thing's just orbiting the Earth, its protection is simply the 4th perspex sheet over that side. And I could never quite get my head around that, because it seemed like, even then I was figuring there must be lots of other stuff flying around in space. Anyway, that's what I was told by the designers. I think this was an X-ray beam splitter where they put samples inside that conjunction of tubes. And they undertake experiments to try to find out what might have been happening very, very close to the Big Bang. So they'll bombard that little tiny sample at the center of all those tubes with particular kinds of particles, X-rays or whatever it is they want. But they can create conditions inside that piece of equipment which get us close in the lab to, if you like, the conditions that pertain to the beginning of the universe, or the Big Bang, anyway. This may look pretty boring, but for me it was tremendously exciting. It's actually, I don't know if you know, but the real Royal Greenwich Observatory is actually in the Canary Islands. And it's 9,000 feet up on the rim of a volcano. And I spent a week up there with the scientists, and they had a large diameter telescope, but even above the clouds, and we were above the clouds, there is still, or at this time anyway, there were still problems with atmospheric interference. And this computer, which I guess looking at it right now is probably about, no, that's smaller than life size. It was probably about 50% bigger than that, was this amazing piece of equipment that basically, with its program, it took all the interference out of the image that was being sent to the mirror. In other words, it made the telescope feel like it was actually out of the Earth's atmosphere, which seemed to me to be absolutely incredible. This is one of those reference pictures, like an axis. This is made at CERN, where many of their discoveries have turned on their heads. Lots of our ideas about how the universe was made, how it came into being, the Big Bang, and so on. Well, I didn't want to turn this on its head because that would be a bit too straightforward, so I've gone for a midway point. And this was incredible too. There were only 2 of these in the world at the time, and when I went to see this robotic arm, one of the operators who had a virtual glove, he said, "Watch this." And one of the things about this was that it could make movements, it could move in directions and in dimensions simultaneously that other robotic arms couldn't. Now I think they're 10 a penny on Fiat production lines and all the rest of it. But he got the glove, the virtual glove, and he very, very gently grasped a ping pong ball in the jaw. And then he said, "Watch this." And he just went mad with this glove like this. And the ping pong ball didn't move in space. It just rotated. But it didn't move vertically, horizontally, just stayed where it started. But this arm was going crazy. And that was absolutely extraordinary. This was a land and sea temperature mapping satellite. Again, I don't know, 60, 70 kilometers up, which could measure the temperature on any point of the Earth's surface or at any point under the sea to an accuracy of something like about 1/10 of a degree. And that's the other axis photograph. I couldn't believe that said gravity on it when I came across it. This is a superconducting magnet. I mean, few of you will know about CERN. So there's like 27-kilometer round ring into which particles are fired. They're introduced from, if you like, a trajectory that comes into the circle. And those particles will then go through something like this, but it'll be horizontal. So when this works, when it's actually working, it's horizontal. But inside there's like liquid helium. And what this means is that the particles enter the core of this superconducting magnet, and they basically exit at much higher velocities than when they enter, because the magnetism, the magnetic fields, are really profoundly influenced by the super low temperatures. So when you have hundreds of those going right around the circle, and the particles are going in at one speed and coming out, say, by a power of 10, then by the time they've gone around 27 kilometers, they're traveling very, very quickly. And this was an older version, but still in use, of the same piece of equipment. And this was a rocket motor in Bremen, in North Germany, an Ariane 4 rocket motor, the European Space Agency. And that was absolutely extraordinary. We've all seen rockets taking off and the plumes of smoke and thrust coming out of those funnel shapes. Well, here, you just see the beginning of the funnel. This is about 10 or 12 feet high, and then the funnel goes down about 10 meters, just from below that point. Kind of awesome. Maybe this is like, really leaves some people here incredibly unmoved, and I find it absolutely compelling, because in a sense it seems to me that science, our preoccupation with our curiosity for the world around us, which feeds into science and which science enables us to work with, is such an impossibly natural aspect of being human beings. So for me, there's nothing unnatural about us designing and making things like this. And I think the future, obviously, is going to hold very much more remarkable things in some ways. But of course, at their time, they are absolutely cutting edge. Going around the world to lots of these scientific sites, I very often had to put on funny clothes. And what I mean by that is like protective clothing, because particles above a certain size weren't allowed to enter the working environment. They were called clean rooms. And I guess towards the end of working on this series, I'd begun to think about those tiny particles that these scientists were really keen to keep out of the clean rooms. And that started me thinking about dirt, which some people, or one philosopher referred to as material in the wrong place, which I quite like. So I began to photograph dirt. Excuse me while I just open this. I've been photographing dirt. I just started photographing mud and stuff. I mean, the way I work very often is I don't dream up an idea and then sort of illustrate it. But I'll have an idea, a starting point. It might be quite a slight feeling. I begin to make work, and then I have to wait and read the work. Because my work, amongst other things, I think takes advantage of upsurges of energy from the subconscious mind into the conscious mind. And there's no way I can anticipate where that's going to go. So I just have to give some loose framework for myself to be in those situations where that process can take place. So I was photographing mud, dirt, twigs, stuff under the sink, working with those sorts of subjects. And I've been doing that for a couple of months. And then I got a call inviting me to be a visiting artist in a physics laboratory in Scotland, in Glasgow, at the University of Strathclyde. And in fact, with a poet. We were both meant to go into this university for 1 year, make art, and then there'd be a show and a performance and so on. So in this laboratory, they were using X-ray lasers to investigate the fundamental nature of matter at a subatomic level. So, in other words, very high cultural status inquiry into the nature of material, if you like. But I was already photographing dirt and stuff under the sink, which in our society has a pretty low cultural status. And I was working in parallel with these two series of pictures for several months. And then I just thought, no, I want to stick them together. They suggested to me that I was actually making one single body of work. And that became material, which in effect was my proposition that all material is democratically equal in value and importance. And of course, there is this echo with this notion of scale too. From powers of 10, you can see that I might have a feeling that big is no better than small. There's no hierarchical relationship between big and small, because everything big at any scale is made up of very, very small things. So material, that was the book which the German publisher Steidl published in 2002. I'll show you some pictures from the book. With this work I was using for both series, 6x45 Mamiya with a ring flash and a macro lens, because I just wanted absolutely maximum information. And shadows weren't interesting to me. I suppose in a way, I was almost trying to adopt a quasi-scientific approach, or maybe like the dentist, it's the same camera the dentist uses when you see those awful pictures of what happens if you don't clean your teeth. They made their own crystals in this lab because very often they wanted to pass X-ray lasers through very, very, very thin pieces of crystal with very perfect, I suppose, crystalline structure, atomic structure. And they found that when they bought crystals in from other parts of the world, they very often had flaws which completely threw out their results. So they grew their own crystals so they could be absolutely sure of the quality. This is under my sink in my studio in Hackney. So in a sense, I mean, given that all art is a proposition, it's propositional. My proposition here is that if, for example, I designed the world, I'd be equally proud of shit and diamonds. I don't know whether it's relevant to say, but in none of these pictures, any ones I've shown you, have I set things up. There's only one exception to that, which is very straightforward. Some of the machine portraits with colored backgrounds, I accidentally, like, do you remember the blue one with the satellite? I went to photograph that satellite, and it was in the middle of this huge room, full of stuff. But over in the corner was this big blue roll of colorama, and there were two guys in white coats. And I just thought, I asked them if they'd mind holding this blue paper behind the satellite, and it just worked. And it also connected with the idea of making portraits and the history of portraiture, which so often, of course, has actually involved providing an isolating background behind the sitter. But that's the only context in which I've actually done anything to construct a picture. Otherwise, everything is found. I may talk more about that. This was an alloy wheel on a Welsh mountainside of a car which had been torched, and it had turned into that.